Look at this example. Find the stationary points on the curve with the equation y equals 2x cubed minus 15x squared plus 24x plus 6 and determine by finding the second derivative. So here the way to calculate is specified. We cannot use the tabular method in order to decide whether the stationary points are maximum, minimum, or points of inflection. Let's start. We will take the function y. We are going to start with the first derivative in order to find the gradient. It is equal to 2 multiplied by 3x squared minus 15 multiplied by 2x plus 24 multiplied by 1 plus the derivative of 6, which is 0. So we have 6x squared minus 30x plus 24. To find the stationary points, y prime is equal to 0. Now let's factorize. 6 is common. X squared minus 5, x plus 4 is equal to 0. We factorize one more time. The multiplication is plus 4, the addition is minus 5. So x minus 4 times x minus 1 equals 0. So for the first time, x equals 4, and for the second time, x equals 1. Now we need to calculate y when x is 4. We simply substitute in this equation here. Y equals minus 10. So 4 minus 10 is the first stationary point. Now for x equals 1, y is equal to 17. So 1, 17. Both of these represent the stationary points. Okay, now we need to find the second derivative in order to decide whether it is maximum, minimum, or a point of inflection. Okay, we will work with the y prime. Y prime equals 6x squared minus 30x plus 24. We do the second derivative. 6 multiplied by 2x minus 30 multiplied by 1 plus 0. So 12x minus 30, this is y double prime. Now we need to calculate y double prime when x equals 4 and when x equals 1. And depending on the sign of the stationary points, we decide if it is maximum, minimum, or a point of inflection. Now let's start with x equals 4. Y double prime is 12 times 4 minus 30. So 48 minus 30, the answer is 18. 18 is positive. We said that when the second derivative is positive, then we switch it in our mind. That means this is a minimum. So it implies the following. 4 minus 10 is a minimum. Now, for x equals 1. Y double prime equals 12 times 1 minus 30. So we need to substitute it here. The answer is minus 18. So this is negative. That means the point 117 is a maximum. In this way, we calculated the maximum and the minimum by using the second derivative. You simply calculate the second derivative and you substitute the x to find the y double prime and to find the sign. Look at the book. We took the y, we took the gradient, putting that the gradient is equal to 0. Look at this hint. You may be told whether a stationary value is a maximum or a minimum, in which case it will not be necessary for you to check by using the second derivative or by considering the gradient on each side of the stationary value. So if the question doesn't specify the way, you can use the second derivative or the tabular method. And as we did, we found the value of y for x equals 1 and 4. We defined the points, then we found the second derivative, and we defined whether it is maximum or minimum on these two stationary points. You can solve these exercises in the same way. As you can see, there are different forms of the function, x in the denominator or square roots. It is the same concept, but with different functions.